If you have a bigger difference between your equator and your pole, you'll have a stronger jet stream in the middle. But if you have a weaker difference, then you're going to have a weaker jet stream. The thing that climate change is doing, if you look at the surface temperatures, is the Arctic is warming so much faster than the equator. Because we're weakening this equator to pole temperature gradient, we're going to weaken the jet. That's going to create more waves. We're going to see more extreme events.
To show how waves in the atmosphere shape what happens on the ground, the jet stream isn't just for planes. It moves weather along, like a high-speed highway. But when there's a sharp bend, traffic slows, and the weather can get stuck in place. Climate change is making these atmospheric traffic jams 3 times more common and more deadly. This is what happened during one of the most extreme weather events of my lifetime.
On this one, we have the 2021 Pacific Northwest heat wave, and you'll see the jet stream cuts off and almost becomes a circular around that region. Those red colors, those are showing temperature anomalies during the event. And when you are contained in that circle, actually, you also don't see any clouds because weather is almost not allowed in that region.
Certainly for those of us who were there and lived through it, it really felt like you were suffocating. There was nowhere to go. We broke temperature records for 3 days in a row. On the 4th day, the town of Lytton burned to the ground. Over 600 people died in BC alone. I mean, this was unbelievable times.
That's what these atmospheric blocks are doing. That the longer this atmospheric circulation sits in this wavy configuration, the worse those extreme events can get. But interestingly, it's the same sort of atmospheric circulation pattern that causes cold extremes.
Short for Atlantic Meridional Overturning Circulation, the system includes the Gulf Stream, which carries warm water northward. There, it cools, sinks into the deep ocean, and flows back south. The AMOC is what keeps Europe milder than it would be otherwise.
The Arctic meltwater is releasing fresh water into the surface ocean. If you add too much fresh water, then the water never gets dense enough to sink, and so that stops happening. And then that changes the way in which the whole ocean circulation develops.
The AMOC is under pressure, and tracking such a big system is hard. Scientists don't yet know when all this fresh water might jam the planet's conveyor belt, or how bad it could be. But one key place could hold important clues: the Florida Straits. Between Miami and the Bahamas, the Gulf Stream flows through a narrow channel at full force.
The Gulf Stream contains the water that eventually will overturn in the northern North Atlantic. If the Gulf Stream is weakening, that's a sign that the overturning is weakening.
It often floods here even when it hasn't rained, something known as sunny day flooding.
In Miami, we don't always know when to expect, really bad flooding, because it's not just the tides, but the strength of the Gulf Stream and the amount of heat it's carrying can also change sea level. The sea surface is about 1 meter higher in the Bahamas because of the Gulf Stream.
So they wouldn't have the same rise in seawater.
Exactly. Strength of the current is proportional to the difference in sea level between Miami and the Bahamas. We have the lower sea level, so if you can imagine if the current weakens, then the sea level could go up at the coast. And so we're trying to understand that aspect more.
With a flood of new ocean data pouring in, leading climate modeler Ben Kirtman analyzes how ocean systems could change in the decades ahead.
So this picture is just showing you surface current speeds. This ribbon, that's the Gulf Stream. You see these less bright colors, the current is weaker than normal. And our estimates seem to suggest that we're going to see a reduction in the strength of that Gulf Stream associated with a weakening trend of the AMOC.
So if the Gulf Stream starts to weaken, and the currents around here start to weaken, sea level is just going to keep going up?
Sea level rise continues. Coastal flood risk goes up, and then you combine that with the ice sheets melting, you get yourself a perfect storm.